So section 9.4 is going to talk about the Pythagorean theorem. So the Pythagorean theorem says that if a triangle is a right triangle, then a squared plus b squared equals c squared. But we also have a theorem that gives us the converse to that, which says that if a squared plus b squared is c squared, so if that is true, then we can say that triangle ABC is a right triangle. And not only that, if C is the one that stands alone, then you know that C has to be across from the right angle. So you know that angle C would be a right angle for that one. All right, so you have three possibilities here. If C is the length of the longest side, you can have what we just talked about, a squared plus b squared equal to c squared, which means you know you have a right triangle. But that doesn't always have to be the case. If a squared plus b squared is bigger, if the sum is bigger than c squared, then the triangle is acute. If a squared plus b squared is less than c squared, then it's obtuse. So if you're ever asked to classify the triangle based on the length of the sides, this is how you would do it. And this is definitely a commonly forgotten concept, so just put a little star next to that in your notes. All right, so it says find the perimeter of the rectangle. So we know it's a rectangle, which means we know we have 4 right angles. So if I just look at this one right here, I can use my Pythagorean theorem, which says a squared plus b squared, equals c squared. When I solve, I get x squared equals 144, so x is 12, which means opposite sides are the same. So 12, 12, 5, and 5 makes 34 units for my perimeter. We can also use this with a rhombus, because in terms of rhombuses, if the diagonals are 6 and 10, we know the diagonals are perpendicular bisectors of each other. So if they were 6, now they're 3 and 3. If it's 10, now it's 5 and 5. And for each triangle, we can use Pythagorean theorem. So when we do that, we get x to be radical 34. But if we want perimeter, there's 4 of them. So it's 4 radical 34. And then don't forget that you need units on there for that. All right, so anticipate any time you have a right triangle of sorts or can create perpendicular, usually Pythagorean theorem is used. So it says find the altitude of an isosceles trapezoid whose sides have lengths 10, 30, 10, and 20. So we've got, again, if you're going to draw isosceles, 2 of the sides have to be the same, and we know they're 10 apiece. If I'm choosing to put my shorter side on top, then it has to be the 20 over the 30. So you want it to visually make sense. We are being asked to get the altitude. So what I'm going to do is from each point, I'm going to drop a perpendicular, which creates a rectangle inside. So if I have 20 and 20, that leaves me with 10 left, which means I have a 5 and a 5 on the outside. And I can just pick one of those triangles and do Pythagorean theorem with it. And it comes up x being radical 75, which would get me 5 radical 3 for the altitude. Now, just as I was saying before, if you're ever asked to classify the triangle and you're given 3 sides, use the idea of a